Hi, welcome back to Introduction to Linguistics, discussion number 4 and 5 for week 4. First of all, before I start the discussion, I want to make an apology that I wasn't able to make this video and upload it by time that I promised. It was because I was sick for a week. It was not like COVID related symptoms, so you don't have to worry about that. But anyway, I'm very sorry to upload this video very late, and consequently, I won't be able to help you to solve the homework 4. Instead, I'm gonna just give you some review on how to solve the problems from homework 4 so that you can understand why you got some problems wrong or right, and make help you prepared more for the quiz that is upcoming. Okay, so first of all, I will recap all the materials that were covered in phonology section in the lecture. It's gonna be a little bit lengthy video, I guess, but anyway, let's move on. So there are a few key concepts that you have to keep in mind in phonology. So basically, natural class is a group of sounds that sound similar, but it doesn't. It's not like very simple definition. All the elements in that natural class have to share a certain phonological feature. So, for example, this is a table for English consonants, like 25, all 25 English consonants are here. And if we choose some elements to be a natural class, you have to be something like, for example, a natural class for alveolar. There are one, two, three, four, five, six, seven, total seven elements in a natural class called alveolar. If you group that in that way, or a natural class can be defined by multiple features, multiple traits. So, for example, if I choose only alveolar and voiceless, how many do you think there are in this natural class? So there are seven alveolar consonants. There, all the voiceless consonants are on the left side of each cell. So there are T and S. There are voiceless alveolars. So T and S form a natural class called voiceless alveolar. Um, some categories fall into can be categorized into a bigger category. For example, stop and fricative and affricate are grouped as obstruent, and all the other are grouped in sonorant group. And liquid and glide, they're often grouped together as an approximant. So, for example, if I say and find in a natural class of voiced approximant in English, how many are there? There's LR, 2, yod, like yaw sound in palatal place, and there's wa sound in velar. So the voice approximant natural class in English consists of L, R, ya, and wa. So 4 of them. This is a natural class for voice approximant in English. Um, Also, place of articulations can be grouped into bigger groups. So bilabial and labiodental are grouped together as labial because it uses your lips. And from dental to postalveolar, it's called coronal. And for palatal to velar, it's called dorsal. And glottal is grouped as a laryngeal. There are other places of articulation that fall into a laryngeal category, but in English there is only glottal consonants that is laryngeal. So if I say find a natural class of a coronal Fricative. Coronal is here, and fricative is here. So this section, there are 6 elements: tha, the, sa, za, sha, ja, grouped into together in a natural class called coronal fricative. Um, if I say something like, uh, is there a natural class of tha, the, sa, za, and sha, but not ja? So without this, 5 of them, is there a natural class that can group all these 5 elements? No, because if the natural class is defined by a coronal fricative, um, it should include all 6 of them. Or if I say a voiceless coronal fricative, it should only include 3 of them: tha, sa, and sha. There is no way in this table to group only these 5 elements together as a natural class. So these 5 elements will not um, form a natural class. Likewise, if I say, is there a natural class that can group fa and ya, like these two? No, because there is no way you can group only these 2 elements without including other elements, other consonants in English. And this concept of natural class is important. You're going to see this more often in the back because there are certain rules, like phonological rules, that are um, applied to every element in a certain natural class. So, for example, there can be a phonological rule in English that is applied to these 6 consonants in English: tha, the, sa, za, sha, ja. But it is impossible that there is a phonological rule that applies to only 5 of this, because these 5 cannot form a natural class in English. It cannot be defined by a certain feature that is shared by all these 5 elements without including any other elements. So that's the concept of natural class. And then phonetics and phonology. So phonetics was about a study of sounds, but in a more physical way. So how they're pronounced and how they're conveyed and how they're processed in our ear. So those kind of concepts that are more physical is phonetics, while phonology is a study of speech sounds that are organized in your brain. So phonetics is about your tongue. It's about how like physical entity of those sounds are produced and they're perceived in our ear or anything. But phonology is about how those sounds are categorized in our mental framework, in our language within our mind. So, for example, there is a concept of phoneme and allophones. You'll be very familiar with these concepts by now. We're in week 6. So, for example, no. So, like T sound can be pronounced as ta with aspiration, and top, tire, token, especially in a word initial position, or it can be pronounced without aspiration in words like stop, strike, or stake. Those T's in a consonant cluster are never aspirated. Or also, there's another way of pronouncing this phoneme. For example, flap R. This sound is ra, so it's not like English R. It's not ra. So, for example, in a word like letter, battle, or uh, little, those T sounds within a word is pronounced as a flap. It's called flapping rule of T in English. So these are allophones that exist in English. It's a phonetic realization of a single phoneme T in our mind. So when we hear tire, token, stake, stripe, and letter, little, we all perceive those different T sounds as a same single consonant T in our mind. When we hear it in our brain, it processes all these different physical sounds as a single segment in our brain. So that's why a single phoneme can be realized into many different allophones, while phonemes only exist in our psychology, in our brain, while allophones are can be distinguished by analyzing our tongue and our sound wave of that sounds more physical in a more with a more physical method. You can distinguish these allophones. So all the phonemes are always written in these two slashes, and allophones are always written in between the square brackets. So whatever it is in our brain, whatever it is psychological, should go between these two slashes, and whatever it is physical, and it's a realization of that phonemes is a allophone should go between these two square brackets. So that's the whole concept of phoneme and allophones. A single phoneme can have multiple allophones. And minimal pair is a set of two words that are completely same except only one segment. So, for example, word like kite and height, they look very different when we see the spelling, but if you pronounce it, it's kite with K and a diphthong and T, height, H and diphthong I and T. These two words sound the same except only one segment at the beginning. So this set of example, kite and height, is a minimal pair because first they sound the same except one segment, and second they have different meanings. For example, in Korean language, there is no distinction between R and L because they are a single phoneme in Korean. So when you say a word like radio, in Korean, you can pronounce this word like radio using R, or you can also read that word like radio using L. Radio, radio. They are um, they are also a pair of two words that sound the same, except the sound at the beginning. But they do not form a minimal pair because it does not satisfy the second criterion here. They don't have different meanings. They sound different, but they mean the same thing, radio, in Korean language. So in Korean, radio and radio are not a minimal pair because they do sound the same, but their meanings are not different. Their meanings are the same. So that's why R and L is not a separate phoneme in Korean language. But in English, if you say right and light, as in word like right and light or light, they are all different words. They sound the same except one, and their meanings are different. So they are example of minimal pairs in the English language. This example, right and light, is a minimal pair of R and L sound in English. So that's the concept of minimal pairs. So whenever a set of two consonants, set of two phones, set of two sounds have a same environment and they mean a different thing, they're said to be there in a contrastive distribution. So, for example, um, R in right is actually in an environment that looks like this. This is their environment. And here in English, both sound R and L can be in there. But for example, is um, like velar nasal ang sound can be there in that environment. In light, in English, is there a word sound in light? No. So this consonant cannot go in that environment, but these two can, ra and la. So if two separate sounds appear in a single environment, there are many different environments in this language, and in certain environment, these two sounds can coexist, and they mean a different thing. That's why these two sounds are said to be having a contrastive distribution. If two sounds can exist only in a different environments, they are said to be complementary distribution. So for example, in English language, T sound, ta, has many different allophones. T with aspiration exists only word initially or in front of a vowel that is stressed. So politician, T sound, the syllable T is stressed. So that's why the T in front of the E is aspirated. On the other hand, T with unaspirated T can only exist in a consonant cluster. For example, strike, staple, and so on. And also in front of a vowel that is not stressed. Like, for example, fantastic. Tas is a stressed consonant, a stressed syllable. Tick is not stressed, is an unstressed vowel. So fantastic, you say fantastic, you don't say fantastic. Fantastic. So the T at the end does not have an aspiration. So there are two environments where T without an aspiration can fall in, and there are two different environments that only a T with aspiration can fall in. So there is no overlap between these environments that these two sounds can exist. So these two sounds are said to be having a complementary distribution because they two complement each other in the world of environments. So that's why these two sounds are regarded as allophones of a single phoneme. So that's the concept of contrastive and complementary distribution. So all these process that I used to analyze this phoneme, to analyze if there is a phoneme or if there's a multiple phonemes, can be summarized into into a process called phonemic analysis. You have to first find the minimal pair, and then You identify the environments for each and generalize them, and then find which one is a restricted one and which one is an elsewhere allophone. And then you schematize a phoneme using the data you found. Okay, I will give you another example. These examples are from the lecture slide. In Tagalog, D, the plosive D, and the flap R um, can be a single phoneme or not. So let's see. This is a list of words that contain D sound. This is a words containing the flap R sound. So in the first 5 example, D exists in word initially. So this pound sign marks the word boundary, either the start of a word or the end of a word. So it is the environments that D exist in these list of words is word final position before ah, or word final position before oo, or here between n and u. Also here, same in mandurukot. It's between D is sound. D is currently in between n and u sound. And flap R here exists between and or and oo, and oo and oo. And you can simply compare these two set of environments and generalize that here on this second list, it's only consists of 2 vowels. And here, there is no such between vowel environment in the first list for the environments for D. So you can say that these R sound exist only intervocalic position. So vocalic means vowels, intervocalic means between 2 vowels, and D sounds exist all the other environments. So that's the generalization of the environment. And then, since you have more different types of environments here, it's easier to make a phonological rule in a way that these sounds is default sound, because it occurs in a more various environments. You can have only one single rule to derive the R sound from D if we choose intervocalic position environment as a special case. So you can have 2 possibilities. One, having D as a default sound and derive a rule that derives sound R from D. And another possibility is to set R as a default sound and set up a rules that derive D sound from R. But in that case, you have to have at least 2 different environments, 2 different criteria. For example, one is word initial position in front of a vowel, and the other is after certain consonants such as N and before a vowel U. So there is no single rule that encompass these 3 environments. So it's easier to set D sound as a default and R as a special case. And that's how you make a default consonant D as a phoneme and allophones D and flap R with environments elsewhere, intervocalic. That's how you analyze a phoneme. And if you find a minimal pair, you don't have to go through all of that. So H and glottal stop a, ha, and a in Tagalog are two different phonemes. How do you know that? Because we have a minimal pairs here. Kahon and kaon. Box to fetch. Or umangos and humangos. To flow and to faint. They are a set of words that sound the same except one. Here, kahon and kaon. They're a set of two words except that sound the same except a single sound in the middle. What about this? Ari and hari. They are not a minimal pair of these two sounds because they are not the same. They don't sound the same except one. They're different in two positions. So if there is a minimal pair that corresponds to ari, it should be hari, not hari. You got it? So these set of examples is not a minimal pair, while these are. So in Tagalog, ha and a are two different phonemes that correspond to a single allophone for each case, and da is a phoneme that has two allophones, da and flap r, where r occurs only in intervocalic position, while d occurs elsewhere. Okay, let's move on. Phonemic analysis of Japanese ka and ga. So there's a set of words: kiri, kaku, genkan, gaku, gambare, goku, kantan. Can you find a minimal pair? Yes, here, kaku and gaku. So in the same environment, two sounds ga and ka can both exist, and they do mean the different thing. Kaku means to write, gaku means to study. Therefore, ga and ka have a contrastive distribution. They form a minimal pair, kaku and gaku, and therefore they are two different phonemes. Like this. On the other hand, Japanese N and M, benri, hentai, kantan, gambare, shinpai, sanji, genkan, senbei, shinbun, hanbun. In these list of words, N exists in here, and M exists here. And you can list all the environments that exist in this set of words. So for example, for M, it's between E and B, between I and B, between A and B, and I and P. There are 5 different examples of sound M. And actually, there are two examples that overlap. It's a same environment between a and ba. So there are 4 different elements we found out where M can exist in Japanese. And also for N, between e and ra, and e and ta, a and ta, a and word final position, a and za, e and ka, a and word final position, u and word final position, and the same environment over here. Okay, you categorize, list them in a 2 different row. So for N, there are these 7 different environments available for this N to exist. For M, there are these 4 environments. And you can see these N all exist after a vowel, e, a, u. I don't know what kind of natural class can have e, a, u in Japanese. But also, M sound exists after vowels too, a, e, e. So we cannot find a criterion by looking at the sound that coming before these two sounds to decide whether N or M should come. But if you see the right part of this environment, you can see ba and pa sound exist here in the list, but not in this list. So you can conclude that M sounds exist before B or P, and N sound exists before R, T, K, Z, and word final position. And you learn from the natural class concept that B and P can be defined as a natural class of bilabial. So in a more elegant way, you can say that M exists before bilabial position and N exists elsewhere. So we set N as a default sound because it's easier to make a rule that derives the M sound from N by denoting an environment that in front of bilabial. It's hard to make a set of rules that decide these 7 environments. So you can say there's a single phoneme N, which I set as a default, that can exist as M or N. They can realize as ma sound or na sound decided based on the environment, the position that phoneme exists. So before a bilabial sound, it's M, and all elsewhere positions, N, the default sound, come out. So that's how Japanese phoneme N is organized. We can move on to the next example. Italian N, an Ng sound. N is an alveolar nasal. An Ng sound is a velar nasal. And in the, let's see the list. For the examples of N, tinta, tenda, danza, nero, gente, sapone. And for Ng, tingo, fungo, anche, bianca, tengo, fango. That's Italian. And you extract the environments out of these words. So there are 6 environments for N sound, another 6 environments for the Ng sounds. And you have to generalize these lists. So it's always either after a vowel or a word initial position. But for the vowel, there are a, e, o here, and a, e, u. There are overlapping vowels, and you cannot generalize using these vowels. So it is clear that the vowel coming before is not the parameter that determines which allophones to come out. But if you see the latter part, the right part of this environment, you can see always G or K sound come after Ang sound, while there is no G sound or K sound after N sound. So we found a generalization. We found a hint that Ang exists before G or K. And if you see the consonant table chart, you can easily find out that G and K form a velar class. They're velar stops, right? So Ng exists before velar stops, and N exists elsewhere. So whenever you use a single slash and you put sound on the left of it and environment on the right of it, it means that these sound is realized in certain environments outlined here. So Ng sound exists before velar stops, N sound exists elsewhere. Therefore, you find a single phoneme. And what's the default phoneme? The elsewhere phoneme N is a phoneme that has two allophones, ng and n. Allophones are denoted in a square brackets. Ng sound exists only before velar stops, and n sounds exist elsewhere. That's how Italian nasal n sound is realized in different positions. So these ng sound and n sound are forming a complementary distribution, and is different realizations of a single phoneme n. Okay, and if you find certain rules of certain rules, certain allophones with their corresponding environments, you can set up a phonological rule. So for example, in Swampy Cree example, their G sound, ga and ka, is actually a single phoneme because ga sound exists only in intervocalic position. And similarly, ba and pa is also two different allophones of a single phoneme. Da and ta is also two different allophones of a single phoneme. And there always a voice counterpart exists in an intervocalic position. So ga occurs in intervocalic, ka occurs elsewhere, ba occurs in intervocalic, pa occurs elsewhere, da occurs in intervocalic, ta occurs elsewhere. And you can see all these three here and there can be categorized into a natural class, voice stop, and voiceless stop. So this is the point why a natural class is important in our in phonological analysis. You can generalize three sets of phonemes that have two allophones each into a single rule. That is, voiceless stops, because these are default phonemes, voiceless stops are voiced in an intervocalic position while it remains voiceless elsewhere. So basically, you just describe all three rules together into a single sentence. So always you put something phoneme between two slashes. So voiceless stop is changed to voiced. This arrow means it converts to, it's changed to, it becomes voiced in some environments that is between V and V. And V stands for a vowel, so it means this is an intervocalic position. So that's the power of natural class. By using a natural class, you can describe many different rules that are similar together at once. So there are three phonemes in Swampy Cree that has 6 allophones, and they are determined by this rule called Swampy Cree intervocalic voicing rule. That's a big phonological rule that exists in Swampy Cree that is applied to 3 different phonemes and derive and result in 6 different allophones. So phonological rules also exist in English a lot. For example, English approximates here: rye, dry, try, light, blight, plight, you, beauty, pew, and we, dweeb, tweeze. When you pronounce the third column of this data, try, plight, pew, tweeze, these R, L, ya, and wa sound, English approximates, are voiceless, because if you touch your neck and feel the vibration of your throat? Try. The vibration only exists in I part. Try. Root part. When you pronounce R or L in plight, there's no vibration. Plight. Plight. You can feel that the vibration only exists in the vowel. So there are four sets of phonological rules where four different proximants are la, ra, la, ya, wa, each having two allophones. Voiceless version, voiced version, voiceless version, voiced version, voiceless version, voiced version, and voiceless version, and voiced version. And they are voiceless when they are between a voiceless consonant and the vowel. So this is the environment that result in a voiceless counterpart of four different English approximants. So you can, using a natural class, this four sounds are grouped into together in a natural class called approximant, because if you see our English consonant table, approximant is a group including liquid and glide, and la, ra, ya, wa are the English voice approximants. So it's a natural class including four different phonemes in English that all go through a same rule, where it becomes voiceless when it is followed by when it follows a voiceless consonant, voiceless stop. So this diagram summarizes all these four rules into one. That approximant, English approximant, is a phoneme that becomes voiceless when it comes after a voiceless stop, and it becomes voiced elsewhere. Therefore, the voiced version is a default version of these sounds, and you can write a phonological rule out of it, that approximants are becoming voiceless. So you put phoneme here with two slashes, and this right arrow sign, meaning that approximant becomes voiceless, and you put this voiceless, the feature you acquired after the phonological rule, between these two square brackets, meaning that these are phonetic realization of this phoneme, that this voiceless form is not a different phoneme, is an allophone of an original sound. And when that happens, you can see that after the single slash, when the environment is after a voiceless stop. So that's the devoicing rule. Devoicing means voice becomes voiceless. Devoicing rule that applies to approximant sounds in English, which are four of them. So far we learned that phoneme can be realized into many different allophones based on their environment. So you can set up a rule using those environments, and many different phonemes that fall into a same natural class go through a same rule so that they can be grouped together to form a bigger rule that applies to multiple phonemes in a certain language. Okay, another great example is Russian devoicing. Russian also has a devoicing process. We're going to learn about it. This example is also from the lecture slide. When you see the first two examples, it's quite there. You can't find any phonological rule or any allophone coming in this example. Troop and troopa. It's a same word, corp. Corp of it's a two different realization of the same word, corpse. can be nominative when it's in the like beginning of a sentence, and when it's genitive when it's a possessor of another thing, like corpse something, it's a trupa. When you say corpse is something, it's trup. There's no allophony going around here, but when you say a mushroom, grip and griba, you can see that a single sound can appear in two different allophones, ba and ba. But we know that this is a single phoneme because it's coming out from a same word, mushroom. So we have an hypothesis. Okay, then there is a certain phoneme that can be realized into P and B. And as we learned before, let's say, let's set up an intervocalic voicing rule. So it is always voiced when it is intervocalic, and it remains voiceless and elsewhere. This is the hypothesis we set up. But if we check the first two examples, this true pa is an exception to that rule because p should exist elsewhere. It should not exist in an intervocalic position, but in this example, it exists in between u and a, which is intervocalic position. That's weird. So we change the hypothesis. How? By setting up a devoicing rule, where p sound in grip is the result of a devoicing rule that applies only to the word final position. So the default sound is voiced ba, which becomes voiceless, which is devoiced word finally, and it remains the same elsewhere. And if you think these two sounds, pa in trup and trupa, as a separate phoneme, so that in Russian they have two different phonemes, ba and ba, while ba can also be realized as ba in certain positions, while ba can only be realized as ba, as voiceless. A very important takeaway from this example is that a same allophone can exist for different phonemes. We learned that there can be many different allophones from a single phoneme, but we did not learn that there are certain sounds that can be a result of realization from multiple phonemes. So, ba sound in English is a result of ba devoiced and ba as it is. So that's one of the key takeaways from this example. And yeah, these are some wrap ups for phonological rules. So I think I thought this part is very important. So I put a lot of time and effort on it. And I'm going to give you a very brief summary of the phonological processes. So whenever sound is, let's say there's A and B, and when A becomes a sound to A prime that is similar to its neighboring sound, it's called assimilation. And if the B is after A sound, the assimilation happens this direction, and it's called anticipatory assimilation. If B exists here, for example, there's a sequence of sound B and A, and then A changes to A prime in a way that it is more similar to the previous sound. That direction is called perservative assimilation. Intervocalic voicing, so for example, A, Ba, A becoming A, Ba, A, is also a part of assimilation because vowels are always voiced, and voiceless becoming voiced means that it's becoming more similar to the vowel sounds. So it's an example of assimilation, and direction is both ways, both anticipatory and preservative. So There can be three different ways: anticipatory and preservative, and both directions. Dissimilation is a revert process of assimilation. Whenever a sound changes in a way that it is more distinct from its neighboring sound, it's called dissimilation. When some sound is deleted, when it's eliminated, it's called deletion. When some other sound is introduced in between existing sounds, it's called apenthesis. Whenever two sounds changes its position, it's called metathesis. And whenever sequence of sounds is duplicated, it's called reduplication. So these six types of phonological processes are a very important set of phonological processes that exist around the world. Okay, thank you very much. Thank you for watching.